We'll be presenting our project on PPE detection using artificial intelligence, computer vision, and YOLO. So our group members are Deep Thakur, Anuj Majumdar, Premjeet Ghosh, and Rupak Majumdar, and our guide's name is Mr. Sudipta Das. So today I'll be going through the basic functionality of what we've created, why we've created this project, and some more core technical aspects behind how this project functions exactly and how we got it to work on our PCs. So, India is a world leader in what? India has one of the highest rates of industrial accidents globally, which is a significant concern. Factors contributing to this include rapid industrialization, inadequate safety standards, poor enforcement of regulations, lack of worker training, and aging infrastructure. In 2020, India implemented OSHA regulations, which are similar to what we have in the US, which basically created a standard for which all work sites need to follow in terms of safety and in terms of preventing big calamitous accidents. And unfortunately, after these regulations were put in place, most job sites, construction zones, and workplaces did not follow suit and implement these changes. So, what is PPE detection? We are developing a personal protective equipment detection system that analyzes video footage to accurately identify the personal protective equipment worn by individuals. This system aims to help improve safety standards at industrial sites by enabling a more thorough evaluation of PPE compliance. So, when we were looking for a good framework and detection system for our project, we went through a lot of different options like single shot multi-box detectors, RetinaNet, and CentraNet. But in the end, we chose to use YOLO. Why is that? Three main reasons. YOLO has really good real-time performance. The accuracy may be a bit iffy sometimes, but we've programmed around it and created a bunch of fail safes to make sure our confidence rates as high as we can conceivably do at this moment. YOLO is very simple to use with a lot of really good libraries to implement functionality, which takes a lot of heat away from us when we need to develop these systems. And YOLO is very versatile, especially when it comes to like object detection systems and small objects, small to medium sized objects like PPE systems that we're trying to detect. So GPU processing. We use tools like NVIDIA's CUDA, cuDNN, and PyTorch to ensure a program leverages the GPU on my laptop for image processing. Previously, the program relied solely on the CPU, resulting in significant performance issues and poor runtime efficiency. By switching to GPU processing, we've achieved much better performance and smoother operation. So, technology. We've basically used three main technologies: OpenCV, CVZone, Ultralytics. OpenCV provides the core capabilities for image processing, enabling us to handle tasks like video frame analysis and object recognition with efficiency. We are using CVZone to simplify the implementation of computer vision features, making the system more user-friendly and reducing the complexity of code. For the actual detection of PPE, we are using Ultralytics YOLO version 8, an object detection model that helps identify safety gear with high precision and speed. So, methodology. We utilize object detection, a computer vision technique that identifies objects within a visual input. The process typically involves generalizing a bounding box around each detected object and classifying it according to its type. So here, as we can see, there are a few buses, cars, and trucks. What will happen here is there will be a bounding box that we created around each of these objects. We've created a small bar to classify its type, let's say a car, bus, whatever, and we've implemented a small number underneath which calculates its confidence rate. Basically, how confident the system is that what it's detecting is actually that, so that it can combat false positives. So we implemented a simple counting system using masks and a specific counting line where basically objects, when they get to that line, they'll only get counted then, and a tracking system which gives every object a unique ID so they're not counted multiple times. This we are planning to implement to make our object detection system more robust, so that let's just say a job site has 50 people in compliance of PPE standards and regulations and 60 who don't. So we can count people who are compliant and count people who are not. So for our PP detection system, we couldn't use pre-trained weights. When we were testing out all the functionality, we could, but for our PP equipment, we had to custom train our weights. So I first got weights from RoboFlow. Then I used Google Colab to train my data, or train the custom data and turn them into weights. So because we implemented proper GPU processing, I use large weights. And here, as you can see, the PP detection system currently is working pretty well. There are bounding boxes around each object that needs to be detected, and if someone is compliant with PP standards, the bounding box will be green, and if they are not, the bounding box will be red. Thank you.